Okay, problem 36 on 458. You are assigned problem 35. Its sister. This second problem from this set that I've called resolving trig and inverse trig composition composite expressions. I realized that the previous problem, which was problem 12 on page 457, which was a sister to problem 11, and was the problem tangent of the arc sine of minus 1/2. I'm not quite sure how I delivered that. I want to deliver in a slightly different way as a prelude to this problem. And I did what I did primarily because I don't have the discipline myself that I think I need to develop here when dealing with these arc functions. Remember, these arc functions are special, and when I say special, they're very different in a lot of ways from other functions we've learned before because they work only on restricted domains. And so this particular problem starts by you trying to find the angle whose sine is minus 1/2. That's what the arc sine is. It's the angle whose sine is minus 1/2. So how do you do that? Let's just go over to a unit circle associated with this problem, and let's draw a couple signs of minus 1/2. There's a minus 1/2 and a triangle associated with it. Here, right across from it, is another one. So which angle to choose? This angle? Or this angle, or that angle? They're all possible. But remember, if we're going to deal with the arc function, then we have to kind of, while the domain of the arc function is minus 1 to 1, and minus 1/2 is just fine to put inside of the domain of the arc function is minus 1 to 1, and so minus 1/2 is right in the wheelhouse of that domain, but the range of the arc sine is the domain of the sine, and the restricted domain of the sine is minus pi over 2 to pi over 2. Yeah. So we really need to pick this function right here, which in this case is minus pi over 6, minus 30 degrees. That turns out to be minus 1/2. This is root 3 over 2, and we're off and running on the problem. Okay, so this time, the second time through, I did it through another bit of reasoning. This time I stuck right with the relationships of the ranges and domains. So let's go do the same thing here. This problem 36, is, I believe it's a 2-unit circle problem. Let's see if I'm right. Let's change colors, see how many colors we end up with. The first is, let's deal with sine of 7 pi over 6, okay? Where is pi over 6? What's its sine? 7 pi over 6. 7 pi over 6 is 1 pi over 6 past pi, right? So there's the angle right there. And it is 1 pi over 6, so this little angle right here is 30 degrees. 1, that makes that minus 1/2. Yeah, and that's all we want. And we're working with the sine. The sine goes from 0 to 2 pi. That falls, 7 pi over 6 falls in 2 pi, so we're all good. And that says, now let's work the second problem. We just decided that sine of 7 pi over 6 is equal to minus 1/2. Let's go to the second problem here. And let's now just try to decide what the cosine, or the arc cosine, of minus 1/2 is, right? And just as I did in the prelude, let's remember that the domain of the arc cosine is minus 1 to 1. So we're all good. I can put a minus 1/2 into an arc cosine, that's fine. But let's remember that the range of the arc cosine is equal to the restricted domain of the cosine, yeah? And that is equal to 0 to pi. So when we go trying to solve this problem, I'm off as I'm talking, trying to do that, we better be dealing with an angle which is between 0 and pi. And why is that important? It's important because I'm going to mark off minus 1/2 over here on the x-axis. That's the cosine. There are two angles, at least two angles, that give you that minus cosine. It's that guy, or it's this guy. And of course, it's just the first that is between 0 and pi. So I've made a mess here. I'm going to clean it up a little bit. Turns out this is a 3 unit circle problem. So there's the angle that I'm working with. It produces a minus 1/2. That makes this 30 degrees. That makes this 60 degrees. And that makes this angle 60 degrees shy of 180 or 120 degrees, which is the same thing as 2 pi over 3. Okay, so answer 2 pi over 3. We reached it with careful consideration of the domains.